Now, I've seen articles like this, and I'm picking on not the CNCF, but the Linux Foundation today. But it's a lot of people have the same thought. And a lot of people say, but it's only 5% worse at, when you go from a 300 billion parameter model to an 80 billion parameter model. And today I want to explain to you why that 5% feels so bad. We're not even going to cover why that 5% is hard to even measure, and the measurement of these models is broken, why we have the AI games this December 15th. But it has to do with, quite possibly, yet another difference that we're not even thinking about. So, again, I'm picking on the Linux Foundation because they put the blog article out there, but I've seen this a lot of other places. This isn't super new, and I'm going to give you the blog article because they bring up other valid points that I don't want to diminish too much that you should read. And I like the Linux Foundation for the most part. I don't know why I said for the most part. I guess I always throw that in there because there's like a chance that they've done something that I disagree with that I'm not coming up to the top of the head, but it's like, okay, well, for the most part, it's a true statement. I should have been a lawyer. Okay, let's go on. Closed models dominate, but not necessarily because they're better. The first headline from our research is striking. Closed models account for roughly 80% of the model usage and 96% of revenue, even though they cost, on average, 6 more than competing open models. So basically, open models cost less to run. This is based on data coming from OpenRouter, a widely used interface for using open and closed LLMs via API that captures nearly 1% of the global expenditure on LLM APIs. This dominance would be easy to explain if closed models consistently delivered vastly superior technical performance, but that simply isn't true. Open models routinely achieve 90% or more of the performance of closed models on widely used benchmarks. I know that you guys have heard me say that these benchmarks are crap, and that's part of the problem. That is 100% part of the problem. But the other part of the problem is this 90%. 90% to us humans sounds really, really, really good. If you said I had 90% of a tank of gas or 90% charge on my battery, that all sounds really good to us. As humans, 90% sounds good. Now, I'll tell you something. 90%, if you're talking about availability, is trash, is garbage. You can take days off and be down for days every single month. It's garbage. So 90% in the computer world is not good. But it goes even further than this because you don't get 90%. Now, I'm just going to take this 90% of a real model, and we're going to do a little calculation. What I have said many, many times before, but I wanted to demonstrate here, is that we're in a place where we're chaining AIs. We're feeding AIs back into each other, and this input goes into here, and things like this. And so if every step of this thing has 95% chance of doing something correct, the resulting output here, I'm just going to come up with something. It's going to be like 75% chance that you actually get what you want. And this is what's happening across the industry. Across the industry of AI, we're looking at agents. What agents do is they self-ask questions and they self-drive, and there's a whole list of things that are going on. And so when any one step has 95% chance of success, you end up having an issue. Now, we can actually do this really quite simply with a coin flip calculator. Basically, a coin flip calculator looks like this. You have coins here, and let's say that heads is the correct solution. Well, in the chance that we flip 2 coins, if we wanted to get 2 correct answers, and for our system to be correct at the end, to have 2 correct answers, if in the first try you get a correct answer, but the second agent call you get a tails, an incorrect answer, then it's not correct. The whole system is wrong. And so in this scenario here where we do 2 coin flips, you have only a 25% chance that it will be a heads, right? That's how probability works. You don't have 50%. You have 50% on any one flip. Now, we can go and use a coin flip calculator to actually expand on this just a little bit. We can change our probability to 90%. And in this 5-step thing, when we are at 90% of the closed source model, so taking what was given, our probability is 59%. So that 10% that people are talking about, this 10%, it's 10% worse, actually means if you're running it as an agent, which lots of stuff is dominated by agents right now, it means that you're at basically a 60% worse than the leading models. And I think this is a big reason why a lot of those open models don't succeed as much. There's another reason. There's actually probably a couple reasons. One, a lot of people don't want to host their own model. Another reason is that a lot of the times, if you are hosting your open model, you're probably trying to be cheap or running on your own hardware. And if that's the case, you might not be able to run the 500 billion parameter model, 600 billion parameter model. But I think that this, honestly, if I had to make a guess, dominates it. It's just probability. It's probability that we're not thinking about. And yeah, let me know if I'm wrong. Let me know if you think that there's something else going on, something nefarious. Are people getting paid off? I also like to blame the lizard people in this case, but this time I'm not sure it's the lizard people. I think it might be math, but what do I know?